All right, so we're going to do the entry task for 224 or 25, depending on which day you have class. I already started to underline it because my first video wasn't recording, of course. And so hopefully this one is. An 8.5 kilogram ball is rolling 6 meters per second towards a 3 kilogram ball moving negative 16 meters per second. So that's our before. Let's start with that. So I'm just going to call them A and B because that always is easy to do. We know that the mass of the first one is 8.5 kilograms. So if we write it all out, that helps us kind of set up the problem much easier. So it does ask you to diagram, so you might as well just show the A and B ahead of time. So we know that it has a mass of 8.5 kilograms and it's rolling at a velocity of 6 meters per second. That tells us that it's positive and moving to the right. The second ball is got a mass, it has a mass of 3 kilograms and it's moving negative 16 meters per second for its velocity. That tells us it's moving to the left because it's negative. So they're coming at each other, ready for a collision. Now, after the 3 kilogram ball moves away at 2.5 meters per second. So we can set up the after as well, just so it's there. So we know the 3 kilogram ball, so that's ball B. We already assigned it ball B. So that mass didn't change. But now it's moving away at a velocity of positive 2.5 meters per second. So we know ball B is going to go to the right after the collision. The question is, what is the velocity of the 8.5 kilogram ball? So this ball A, which was the 8.5 kilogram ball, mass didn't change. The velocity is what we're going to be looking for. So it's going to be x meters per second. So remember, the conservation of momentum tells us that everything before the collision equals everything after as far as momentum. So therefore, because the momentum is found using mass and velocity, we can add up this side and say that it equals this side. And that's how we're going to solve for the velocity on the ball A after the collision. Okay, so just think about that as you're going. So we're going to use that mass times velocity plus mass times velocity to get the total momentum before the collision. So we're going to start with 8.5 kilograms, which is the mass, times the velocity of 6 meters per second, plus the mass of B, which is 3 kilograms, times negative 16 meters per second. Don't forget your negatives. That is crucial in answering these because it does make a difference in what your momentum before and after is going to be. So now we have a problem here that we can solve. We always multiply before we add. So we have to multiply both momentums or find both momentums before we add them together. So 8.5 times 6 is the first one. So I'm just going to go 8.5 times 6. That's going to give me 51. And I'm multiplying a kilograms times a meters per second. So that's how I know it's a momentum. So that's a 51 kilograms meters per second. I'm going to bring down my plus sign. And now I'm going to multiply 3 times negative 16. And I get negative, don't forget your negatives, 48. And again, it's a kilograms meters per second. It's a momentum. So now that I have like terms, kilograms meters per second and kilograms meters per second, I can add them together finally. Now, if they didn't have like terms, you can't add them together. Got to remember that, okay? So they do have like terms, so I can add them. Now I have to remember that there is that negative, so I want to make sure I get it correct. You could probably do it in your head, but I want to make sure everyone gets it correct. So you're going to go 51 plus 48 negative, and it's going to give you 3. So remember, the momentum kind of cancels each other out because of direction. So we have 3 kilograms meters per second as our total momentum before the collision. Now I'm going to put an equal sign to remind myself that that is going to equal what's over here. Because we're going to do all the problem over here, and we're going to drop it down, and we're going to solve. Okay, so the total momentum before the collision of both of the balls is 3 kilograms meters per second. So now over here, I do the same process. Mass times velocity plus mass times velocity. So 8.5 kilograms, since we don't have a velocity, it's x meters per second. plus 3 kilograms times 2.5 meters per second. So I have to first do my multiplication. So I can't do anything here because that's an x, but I can do something here. So I'm going to go 3 times 2.5, and I get 7.5. So over here is going to be 7.5 kilograms meters per second. So the momentum of the ball B after the collision is 7.5. And I'm going to say plus, and I'm going to bring this down because I can't do anything with it, because I can't multiply because I don't have a number. It's just an x. Now, here's where people make mistakes. They try to add stuff together they can't add. Now, we already solved all of the before, so ignore what's happening on the before. After, we have a kilograms times an x, so we don't actually have a kilograms meters per second yet because we don't have a number for x. And over here, we have a kilograms meters per second. You cannot add that to this 8.5 because 8.5 is just a kilogram. They're not like terms. When you're adding and subtracting, you can only use like terms, and that's different than multiplying and dividing, okay? So no like terms means there's nothing else we can do on that side of the problem. So I'm just going to bring it down so it's equal to the other side, the before. So now I have a problem right here, a single problem, and I'm going to just draw a line so you can remember that we're kind of done with all the befores and after. Now we're one problem right here. So this is telling us that we still want to find x, but we have all these other numbers we have to get rid of to get x by itself. So we have to get rid of the 8.5. We also have to get rid of the 7.5 kilograms meters per second. So it's one long problem. We have to figure out how to get x by itself so we can solve for x. So here's where that PEMDAS comes in too. Please excuse my dear Aunt Sally. So we have a situation though that a lot of people say, ooh, PEMDAS means I have to get rid of it by multiplying or dividing out this multiplying. This is where you get confused because look around, we got to fix like terms first. So if I just were to divide this out, I would end up dividing out the 8 and the kilograms, and I'd end up getting rid of my kilograms, and then I would have this 7.5 kilograms meters per second that I couldn't do anything with because it would not have a like term. Remember, when you do addition and subtraction, you can only subtract or add like terms. Okay, so since this is a kilograms meters per second over here, I have to find somewhere else that has a kilograms meters per second because this is being added here. Not multiplied, not divided, it's being added. So the only other place I have a kilograms meters per second is on the other side of the problem. That means I can get rid of this first before I worry about PEMDAS for the rest of the problem. So to get rid of it, I do the opposite. It's being added. I need to subtract it. That means I'm basically canceling out the 7.5 on that side. But remember, whatever I do to one side, I have to do the other. So luckily, they are like terms. So I can subtract them because of that. So 3 is my number on this side, and I'm subtracting 7.5. So I'm just going to lay out my calculator. So I'm going to go 3 minus 7.5, and that's going to give me a negative 4.5. And it is still kilograms meters per second because it's like terms. So I'm just going to bring down my equal sign, and I'm going to bring down what's left, which is the 8.5 kilograms times x meters per second. All right, so now I'm back to this PEMDAS here. So I've got to divide out what's over here because I really want x by itself. And I'm going to divide out 8.5 kilograms because that's going to get rid of the 8.5 on this side and leave x by itself. Since it's being multiplied, I do the opposite. And I get to do that to the other side as well. Remember, kilograms will now cancel, leaving me meters per second. That's what I'm looking for, x meters per second. And then obviously these cancel on this side, the 8.5 kilograms. So now I'm going to take my 4.5 and I'm going to remember it's negative. Don't forget. I'm going to divide it by 8.5. And that's going to give me a decimal, but you got to think of the real life what's happening. So I'm going to write negative. That's important for direction. 0.5, and I'm going to round up this 9. I'm going to round up the 2 because of the 9. Oops, almost wrote 2 to a 3. So my answer is going to be, the velocity, negative 0.53 meters per second. So which direction did ball A go after? If it's a negative, it had to go to a left. So ball A moved away to the left. But let's look at the velocities. So we started out with A with 8.5. It just barely had a momentum higher than B. But B was traveling pretty darn fast. When they bounced away, B went away at 2.5, and A went away at a much slower velocity because its turnaround didn't have a lot of velocity. So it went away at negative 0.53 meters per second. So that negative matters because now with our diagram, it shows that they moved apart because that was positive and that was negative. All right, let's try the next one. The 1,900 kilogram truck is moving 12 meters per second towards a 1,500 kilogram truck moving negative 25 meters per second. Let me move it up so y'all can see what I'm doing here. Okay, let's start with that because that's the before. So I like to write it down. We have a truck and it's 1,900 kilograms. Oh, I'll just call it truck A instead of writing the kilograms in there. And truck A is moving 12 meters per second positive, so it's going to the right. Truck B is going to be 1,500 kilograms, but it's moving a negative 25, so it's to the left. So let's write those out, mass and velocity, because we still know that the beginning, even if it's inelastic, is going to always be the same as an elastic, where you have both masses and velocities separate. Okay, mass of the first truck, 1,900 kilograms. Mass of the second truck, 1,500 kilograms. Velocity of the first truck, 12 meters per second. Velocity of the second truck, 25 meters per second. Okay, so after the collision, they're going to stick together. So the trucks collided. And we want to know the velocity after the collision. So we do know that when they have a collision and they stick together, they become one mass. So I have to add my masses, 1,900 kilograms plus 1,500 kilograms. Okay, so just to be sure, you can check it because you don't want your math wrong. So 1,900 plus 1,500 equals 3,400 kilograms. And that is our mass now together for the two objects. We are now also looking for their velocity after the collision. So that's really important. So now they're stuck together and they have wheels. So that's why they're going to move after the collision. Well, there's all their wheels. Probably more than that. Notice they have no fronts. They're just box. I'm a terrible drawer, you guys. All right, so we're looking for velocity. That's going to be x meters per second. So we have a mass together and we have a velocity we're going to look for. So we set it all up, but let's solve because we want to solve the before and then solve the after. So mass times velocity plus mass times velocity. So mass is 1,900 kilograms times 12 meters per second plus 1,500 kilograms times negative 25 meters per second. Squeeze it in there. So we have to do the multiplication first. That's at PEMDAS. And then we add. So 1,900 times 12, put that calculator there, is going to be 22,800 kilograms times a meters per second is a kilograms meters per second. That's the momentum. Drop down the plus sign because we're not done. We need to have the 1,500 times 25 negative equals negative, don't forget the negative, it's important, as you remember, 37,500 kilograms meters per second. So now we have like terms, kilograms meters per second, kilograms meters per second. We can add it. I should have just left that sitting in the calculator, but I didn't. So plug it in again, 22,800 plus 37,500 negative equals negative 14,000. I'm going to move it over here so I can have space. So 14,700 kilograms meters per second equals, got to do the other side, remember? So we have our mass times our velocity on the other side, which is just going to be 3,400 kilograms times x meters per second. Now, I can't do anything with that because that x there. So the only thing I can do is move it down to the problem over here so I can have two sides to solve for x. So that's the nice thing about the the inelastic collisions. The after is super simple. Add the masses and put it times the x. Or sometimes in another collision, we might actually, if we did an elastic collision, I might actually ask you to find the mass instead of the velocity. But nothing would change. You'd still just put x what you're solving for. Now, in this case, since we already know the mass is the two added together, we are going to get rid of the mass so we can have x by itself. Since it's being multiplied, we have to divide it. And what we do to one side, we have to do to the other. Kilograms cancel, leaving us meters per second. So I've got 14,700 negative, don't forget that. Dividing that by 3,400 equals negative 4.32. That's as far out as I'll go. I could go one more digit, but I'm going to go one right there because that's a nice number to deal with. So that's a negative number. Which direction are they moving? After the collision, they'll go to the left. So B had enough momentum to, when they stuck together, change the direction of A to the left as 1. At 4.32, ooh, what did I forget? Always have a unit, meters per second, because it's a velocity. Okay, let's try the last one. Adjust that camera again. There we go. So a 16 kilogram ball rolls 4.6 meters per second towards a 10 kilogram ball moving negative 1.3 meters per second. So A and B. And we know the first one is got a positive velocity at 4.6 meters per second. So it's going to be going to the right. The other one has a negative velocity, so it's going to be going to the left. So starting out by just knowing your directions always helps. So let's set up the numbers. Mass of the object A is 16 kilograms, and the velocity is 4.6 meters per second. And the mass of object B is 10 kilograms, and its velocity is negative 1.3 meters per second. After the collision, the 10 kilogram ball rolls away at 3.5 meters per second. So the 10 kilogram ball is ball B, so we already assigned that. So we know that the mass of ball B is still going to stay 10 kilograms, and its velocity is 3.5 meters per second. And what is the velocity of the 16 kilogram ball? So ball A was the one we associated as 16 kilograms. Its velocity is x meters per second, what we're looking for. So we've set it up before and after. We already know the direction of ball B because it's positive 3.5, so it'll be going to the right after. We just need to find out which direction A will be going and what is that velocity. So again, mass times velocity plus mass times velocity. So 16 kilograms times 4.6 meters per second plus 10 kilograms times negative 1.3 meters per second. So I'm going to multiply first my two and then add them together after. So 16 times 4.6 equals 73.6 kilograms meters per second plus, and I have to do the second one, which is 10 times 1.3 negative, which you might be able to just figure out is 13, negative kilograms meters per second. Okay, so now I have a problem with two like terms. I can add them. So kilograms meters per second and kilograms meters per second. So I'm going to do that. 73.6 plus 13 negative equals 60.6 kilograms meters per second equals, so we're all the way done with this side because we figured out the momentum on the before. Now let's do the other side. So 16 kilograms times x meters per second plus 10 kilograms times 3.5 meters per second. I'm going to erase that underlining I had so nobody gets confused with that being a negative. So we already know that this was a positive velocity. We're going to solve for x to find out what velocity that's going to be. So now we're looking at this again where we know that we can't do anything here because 16 kilograms times x is still 16 kilograms times x because we don't have a number yet. So I'm just going to drop that down. But we can solve here. So we can solve 10 times 3.5, which is going to give us 35 kilograms meters per second. Oops, don't need that parentheses anymore. So I'm looking at it now. I got a kilograms meters per second over here, and I have a kilogram by itself, and I can't do anything. I'm done on side after without combining it with the before now. So I'm just going to drop it down. That's all I did. So it looks like I'm rewriting it. Yes, I did. And you can skip some of these steps as you learn how to do this faster, but for the sake of showing everyone how to do it, we want to keep all the steps. So now I have a problem that I can solve. I have 60 kilograms meters per second on this side. I have 16 kilograms times x meters per second plus 35 kilograms meters per second on this side. So what do I need to do? I got to get x by itself, just like we did the last time we did an elastic collision. So again, that PEMDAS here, when you think about it, it doesn't apply when you don't have like terms. You cannot multiply or divide. You cannot add or subtract unless you have like terms. So we want to do that first because 35 kilograms meters per second is a like term with 60.6 kilograms meters per second. So remember, if I divided first, I would have gotten rid of my kilograms and then I wouldn't have like terms anymore. So it's really important to remember, get rid of your like terms first. So if I'm adding 35, I'm going to subtract 35 kilograms meters per second. That gets rid of it on that side. So I'm done with it on this side, but I have to deal with it on this side. So I also, there's my lid again. I also have to subtract it over here at 35 kilograms meters per second because I have like terms. I can do that. So I'm going to go 60.6 minus 35 equals 25.6 kilograms meters per second. So I'm now reduced that down to where I can put my equal sign, and I'm going to bring down the rest of my problem that I haven't solved yet. So I still have to get x by itself. I've got one more step to do that by getting rid of the 16 kilograms. So since it's being multiplied, I'm going to divide it out. That gets rid of it. Ooh, crossed it out. Goodness. Ooh, you guys can't see what I'm doing here. 16 kilograms. Kilograms cancel. 25.6. I already have it plugged in my calculator. And I'm going to divide that by 16 equals 1.6 meters per second. So it's positive, guys. It's positive. Which direction is A going to go? To the right. Slower than B. So it transferred its momentum over to B. B got a little bit faster because it was going the other direction now. And A is now moving after it, but just a little bit slower. Okay? 1.6 meters per second. So that is it.